Hi everyone, this is Lech Muszynski speaking, Oregon State University. Why I'm the speaker here, I need to acknowledge the doer and pusher of the project, this Namyuk An, our graduate student, and then a number of people who contributed to parts and bits of this presentation. Okay, so we are back to the concept of circularity in built environment, and this is our core team. We are funded, partially funded by USDA grant in what we are doing. It's not a secret that not all buildings are forever, right? And that this prompts us to think of what happens at the end of the life. And the buzz term for the day seems to be the circularity, but this is a new buzzword, but a very old concept. Essentially, we've been there for most of our history, and we just somehow lost the paradise, right? And it seems to be the culprit is the industrial era. We cannot reverse this, okay? But I think understanding of the factors moving us away from circularity at the dawn of the industrial era, knowing them should be very helpfully understanding of what are the factors that we are now struggling against. The glossary of terms that I planned for here was nicely covered by Milad. I'm going to return to the reuse and recycle somewhat later in the talk, so I'm leaving this for later. Again, as we've heard, even if the world currently may not seem like perfect to us, steel, concrete, and other traditional construction industries, they already know how to take buildings apart, and to a certain degree, even in sophisticated ways, like you see here, like really the construction of a large building, right? But they also know what to do with the recovered stuff, or actually what happens with it, right? Again, we may not be happy. It's not essentially not necessarily a perfect process. But if we hear it in the best case presented by Milad in Europe, it's like 35% goes to landfill. It's still awful number, but it means that about 65% of the stuff that is coming out of demolition or the construction is finding some kind of second use, right? So that may not be as bad as we think, and it's important not to underestimate the opponent, so to speak. Now, it goes without saying, and this is actually the going without saying is the dangerous thing in here, that wood should be like natural hero in this scenario, right? Circular economy, recycle, refurbish, reuse, repair, and at the end of this, perhaps incineration for energy. And these mass timber buildings can be large, particularly when we're talking about, and my presentation is focused on panelized mass timber buildings. This is one of the largest, at least for some time. It's nearly 4,000 cubic meters of wood in here, right? All prefabricated. Every little piece is made specifically for this project. And it's like common theme. The projects must be designed before any panel is being pressed or fabricated for the end use. They vary in scale. Each seems to be somewhat different. Now, another important part to understand is that the competitive advantage of mass timber over steel concrete is hanging on the notion that the buildings are green and have a great potential for circularity. And this at times justifies going with somewhat higher cost of building or building materials or construction, or just matching, not necessarily being less expensive. Here's an example: Albania Yard, one of the first mass timber panelized building in the West Coast, bragging about the CO2 emission benefits, and it's as a good documented cradle to gate advantage. Now, cradle to gate, again, going back to Milan, this is this part, right? Now, end of use is somewhat more sketchy area, but we are like confident, yes, wood can do that, right? Wood is circular. I mean, it comes from round logs. So here's the moment where we need to think, okay, if we want to make a good use of what comes out of a building being taken apart, we need to consider two options: reuse. And here is the tricky thing. Quite often in our discussions, we forget to define terms before we start, and then it leads to all kind of misunderstandings. Reuse by ISO definition is using the building components or systems even in functions that are as original or close to original without processing, where reprocessing may not include preparation for reuse, such as removal of connectors, cleaning, trimming, things that Erin was talking about. Recycle, on the other hand, would be like comminuting the original elements and using them in some other way than they were originally used. And then disassembly or the construction should be part of this. Now, quite often models that are trying to project into mass timber panels are drawing on the already proven and practiced demolition or deconstruction for light frame buildings, but this is a false similarity. There are like very different cost balance for demolition versus the construction in light frame building. First, demolition is even possible, right? The other is that the construction can be done, board by board, panel by panel, using lots of human labor. This is hardly a good proposition for large panels like this one that can weigh up to 5 tons, right? And then they are made still in very big and heavy elements. So if we consider like demolition options, this would be like standard suite of demolition options. We already see that some of them are just unthinkable for mass timber panel construction. These structures are very good for have very good performance at shaking tables, so are not easily crumbled, not easily ball demolition. They cannot implode, right? There's like no certain ways are just unthinkable for the demolition of large panels. Now, even if there are some that that assume that parts can be just cut out during the demolition process, they end out with resized elements that are very difficult to reinsert in the process of building or construction that assumes how should we put it, customized fabrication of elements for the end project. So the logical path should be like the construction, where you are just removing or cutting through connections and reusing either elements, sub-assemblies, or stories. When I'm thinking about reusing stories, it would be if you have 10-story building and you take it apart, you may reuse the same elements in the same configuration. This would not require any refabrication in a series of smaller buildings, right? And we checked just that. This is a little LCA exercise that has been done by Christina and Maureen on a building that has certain assumptions focusing mostly on the first life and the end of the first life and the beginning of the second life of a building. 9 different scenarios have been tried for CLT and glulam. And we've just selected 2 extremes just to see, for this presentation, just to see how it works. And why the high reuse rate, like 90% elements reused and the building rebuilt, essentially the same building on the same place. So there is no transportation or logistics involved in here. Loses, hands down, with landfilling the entire thing. And that's troubling, right? I mean, we feel in our hearts and minds that this cannot be true, but we cannot dismiss it without evidence. And the evidence is actually hard to come by. And this is because even as our current focus is on how much can be recovered, what is the value of the recovery, what is the cost-benefit balance of this, we are still missing a information of deconstructibility of this large panelized building and any empirical data to verify viability of circular scenarios. These are missing. And the large literature review that Namiuk has performed revealed as many highlights as gaps. I mean, literally holes in the information that would be needed to fill this. Another survey, right? I'm not going to go through the details of the survey. Also, part of Namiuk's dissertation shows gaps between the perception and of importance and readiness. And then Namiuk is still working on analyzing these connections between the perception expressed by professionals and what we found in the state of the art in here. So now let's take a look at this way. This is how the production of CLT grows across years. It's almost like exponential growth between the orange dots being estimates and the blue dots what we can document. The first building was in 1995, which means that there is good reason behind the lack of data for end of life in the CLT buildings, because if we just project it in the logarithmic scale, right? So this is still this exponential growth in here. This is our data. This is where we are. If we project it to the future, actually the first deconstructions are going to happen like 50 years since this first building occurred, right? So this is like way in the future. Few buildings mark the halfway mark of their service life. And then again, if you think of the differences and why the light frame is not being a good model for this, even as the data exists, is that it's very much easier to think of reuse a 2x4 as another 2x4 in some other building, or a window in some other building, or brick as brick in some other building. It's much more difficult to think of element like this that is specifically cut and made for a specific element in a building to be used in another building that may have different shape and call for different stuff. How are we going to approach it? I mean, should we wait another 20 years until the first buildings are being demolished? We think not. I mean, in the meantime, we have like short life cycle structures, panelized structures that are being put together just for testing, and quickly after that removed. That means essentially deconstructed, not demolished, right? Orderly put apart. From this, we can learn many things, as Namiuk is doing right now. Workflow analysis can be determined on real cases, or the evaluation of reusability of recovered elements, element by element, right? That takes into account all kind of changes that are being made between the original design and actual construction, and all kind of damage that may happen during the service, which for test buildings is quite intense. They are being subjected to abuse, right? And then the deconstruction. So the next thing is that I touched on, where are you going to use this precast thing? And we are thinking, well, again, in buildings, right? But in order to be able to reuse them in these other buildings, the buildings have to be somehow connected. They need to be similar. It does not, you cannot use the rectangular elements from one rectangular building into triangular elements in triangular building. This would require a processing. It would not be reusing any longer. So it makes all sense not only to evaluate the reusability at the time of the construction, but actually evaluate it as soon as the decommissioning happens, or actually even better, at the design of the first building, where the deconstructibility and the end use in the new building is already conceptualized at some level. It is hard to predict what's going to happen 50 years from now, yet we must, right? So this thinking has to be infused in the end-of-life scenarios at the time where the first building is being designed. But there are more hurdles ahead. If you think about it, whatever you recover from the first building will have to go through the same scrutiny as the new materials before you put it in to new building. And this is beyond just aesthetic and hygiene, is actually the legal requirements, structural performance, and so on. Somebody is going to have to put stamp on this material or elements recovered and guarantee that they are going to perform. So here is a little summary. While there is a great potential for circularity in mass timber buildings, there is also a set of non-trivial challenges. I'm not saying barriers, challenges to be overcome through research that is ongoing as we speak in here at Oregon State University and elsewhere. So first, the size and weight of individual panels just limit the options for demolition. We cannot see right now what would be a good demolition strategy for this kind of building, even if you selected to do so. The size and weight of the panels pose also challenges for orderly and cost-effective deconstruction. These are heavy elements and have to be dealt with somehow. It cannot be recovered, by hand with a hammer. Recovered elements and sub-assemblies are not easily circled back in the production cycle of a specialty custom-made mass timber panel building process, where everything is manufactured to specific design, right? Then the design for deconstruction, and we need to add circular reuse, emerges as a necessity, not an option when it comes to mass timber panels. New approaches have to be forged before the mass timber panel structures reach the retirement age in numbers, right? Right now, this seems like no problem because nobody is dealing with this problem currently, but is going to come about the same exponential rate that we are building them right now. It is not easy to plan for the world 50 to 100 years ahead, yet we must. And knowing how we got here is crucial for finding our way out. And we should say that conceptualizing in abstract, we've just demonstrated it. Conceptualizing in abstract, in absence of data, leads to quite often to counterproductive oversimplification and blind spots. The devil seems to be in the detail that pops up when we try doing things for real. And we need to try doing things for real in order to find out how things are going to go. So we need to go beyond speaking circularity and assuming things to practical garnering of knowledge, empirical knowledge. And that would be all of my spiel.